Hello then, welcome to this workshop on working with dates and times data in Python. My name is Valentine and I'll be your instructor. Sometimes when we are answering research questions as either data analysts or data scientists, we might need to use data that contains times columns, or it could contain date columns. So in such situations, we may not necessarily be able to apply the techniques that we would conventionally use for just working with any textual data or textual columns or numerical columns that we might have. And as a result, we might need to work with specific techniques geared towards handling times data and dates data. So this workshop is more towards learning how to use those techniques using the Python programming. So let's get started. The first thing that you need to do is to visit the description link of this video. That's in the description section. Click on the practice resource link. That should take you to the page that you see on your screen. Once you get here, sign in and you get to the sample notebook page once you just click on continue learning. And once you get here, the first thing that you need to do is to save a copy and you can get started. So I am going to be using the practice notebook, so feel free to also upgrade your account if you want more challenges to be able to work on the techniques and to be able to practice those techniques more. So, right, so the first thing that we're going to be required to do is just to import the prerequisites. This just entails working with the pandas library, and let's do that. But before I do that, let me just open this in playground mode so that I do not make changes to the original copy of the notebook. So yeah, so run the first cell under prerequisites. So that's going to import the pandas library. Then once we're done, then we can go into the first concept, which entails converting string data to date time data. So initially, if we have a data set that looks like what we are seeing here, this data set contains information about traffic flow. So let me just close this so that we have a bigger space to work with. So assuming that we have this data, it contains this date information. There's actually times information on this particular date, time, and time information on this column, as well as in the incident column. So if you wanted to convert the data that we have, which would initially be in string format, we can use the toDateTime function. So we get it from the PD, that's the pandas data frame of the pandas library, and use the toDateTime function and pass to it the column that we want to convert to date type, and that's it. We just replace the original column values with now the new column values, and then we can display that. So the result here would be that those two columns would contain now date time type of data type that you can be able to apply date time functions to. All right, pause the video and then work on the challenge. Moving on, we might want maybe to convert not our string data that we have originally. So assuming that we have again this other data set that contains traffic flow data, if we have time data here, we might want maybe to convert it to initially it would be in string data format. So I can even just quickly display how that would look like. Let's check the data types, D types. If we run that, we should be able to see that the column names D types. So initially what we would end up having here, if you look at the columns, these are just the data types that we would get for the column, but it just gives you an idea. So for example, we have object, which these are the times data, but if you wanted to convert them to have time delta objects, not just string objects, that we can apply time functions. So we can use time delta function and would convert the respective column. Let me just change this to D types. You can change it to D types You don't necessarily need to do that, but yeah, but if I change this, you can see that duration column, the one that we initially had here, from an object now has time delta data type. Right, pause the video and then work on the challenge. In some other situations, we might want to extract date components. So we might want to extract maybe year, month, and day from a column that contains all that information. So for example, if we have this date column, we might want to extract maybe the year or the specific month or even the day. To do that, we can use the following attributes. So you can apply, say for example, for date, we specify the column name. That's after converting our date time, our string data, initial data to have a date time format. Then we can say dt.year to get the year components, data or the years, the same case with months and the same case with day, and we can display the output because now here we would be creating new columns which have now the respective data that we've extracted. Awesome. All right, let's move on, pause the video and then work on the challenge. So here we have seen that we can extract year, month, and day components from the date column. So assuming we wanted to extract now hour, minute, and second from the timestamp column. So even you could also extract it from a date column if you have the date time data, if you have such data. So assuming this is the data that we have, wanted just to extract the hour, minute, and seconds, we first of all convert the column from a string to a date time data type, and then once we do that, we extract the hour, minute, and the second components from that particular column, the timestamp, and then we store that in new columns called hour, minute, and seconds, and we can display the output. Right, pause the video and then work on the challenge. We can also decide to extract maybe weekday. So instead of extracting the time aspects or the date aspects, we can extract the week aspects. I'll call it just the week aspect, but so assuming we have this data, we can extract weekday using now the dt.weekday attribute and create a new weekday column. So like for example, 5 would correspond to Friday, 6 would correspond, no, actually 5 would correspond to Saturday, 6 would correspond to Sunday, 0 would correspond to Monday. Yeah, that's it. All right, pause the video and then work on the challenge. We can also handle time zone localization. So if we have some data that contains some original information that still in relation to time, assuming we have this particular time, but it could be in a specific time zone. Maybe by default it could be in maybe American New York time zone that we see here. We can decide to make that conversion by converting, so performing this conversion, convert timestamp column to date time format. So that gives us what we have here. Then we set the timestamp column as the index. Then once we do that, we can just decide to localize, but you do not necessarily need to do this. You can still do this. But then again, that would mean that our data would be in that particular time zone. And then we can display the output. And yep. So yeah, so that's it with regards to that. Yeah. Right, moving on. In some other situations, you might want to filter data by maybe a specific date range using between. So we could decide to, maybe if you have this data set that you see here, we might want to maybe filter data by this actually using the date column. So initially we need to convert the date column from string to date time format. Once we do that, we can now perform filtering using the between function. So what we would need to do is to specify our condition, again still using the between function, where we specify that this is the date column that we want to check to use to be able to perform our filtering process, and we want to check for the start date for the records with the start date between this particular value and this particular value, which is the end date, and that would give us now the filtered records which have dates between those values, inclusive again of those particular start and end dates. Right, pause the video and then work on the challenge. In some other situations, you might want to filter data by using Boolean indexing. So for instance, we might want to Boolean indexing. Still, again, this is part of filtering. So here what we did was just Boolean indexing as well. It's only that we use the between function. That's in this particular case. Because this is a Boolean mask, what I have highlighted, it's called a Boolean mask. But for Boolean indexing, what we can do is to still again specify our conditions. So assuming that we want to perform filtering based on whether the records have dates between a specific date range, then we can set aside, we can say that for this particular case, say for example for this condition, you want to check for this condition as well as also this condition. So here we are creating our Boolean mask, which contains these two conditions. So where date is greater than or equal to the start date, which we've defined here, and also date is less than or equal to end date, and to get filter for that and display the filtered data. Awesome. Pause the video and then work on the challenge. In some other situations, we might want to resample data, say for example, from daily to monthly. So if we have this data set that we're going to load here, we can decide to resample. So it could be that we might want to have a frequency of weeks. Instead of having days, we could have weeks, of months, or quarterly. But to do that, maybe to resample this data so that we have some sort of format that we want for monthly, say from resampling this data from daily, because you can see what we have here, it's just daily date. We might want to resample, so we apply the resample function. So once we have actually initially converted our date from the datetime format from a string format to a datetime format, we can then decide maybe to set the index as a column, then decide to apply the resample function, and we specify inside the function m to specify that we are resampling the data to monthly format. And we can even also perform some monthly averages. So for example, for speed, we would actually have a resampled data that contains, in our case here, mean, and for volume we also would have mean. We could decide to have minimum, maximum, depending on the research question. Then we can display the outcomes, and you will see here we just have data in one particular. We only have data that runs across 1 month. That's why we are getting what we see here. But what if we changed this to week? So we can just change that to W. Capital can just I need to run this so that we have a fresh data set to have weekly. So you can see we have data that actually, it doesn't actually cross, the data set is not big enough to give us lots of resampled records. So yeah, we have that as an outcome, and we can use this maybe for further analysis. Right, pause the video and then work on the challenge. We have a few more, 5 more concepts. I think resampling data, we've done daily to weekly, so we just need to change what we have in here. In this case, by the way, let me just load this data set. So in this case, we are doing just resampling weekly. We have a date, and you can see date, it's just daily. And we can set the date column as the index, and then we can resample data. But here we would decide to calculate, to work with that we want to calculate the amount for weekly to be that of mean. So for every record for the week, we would have the amount, the mean amount. So let's run this, and we should be able to see that we have what you can see here. All right, pause the video and then work on the challenge. In some other situations, we might want to calculate maybe differences to determine how much time elapsed between two dates. It could be how many days, how many weeks, how many years, etc. So assuming again we have this data set, we might want to maybe convert. First of all, we would need to convert the date time, the data that we are working with. That's date, our data, to have a date time format, and then once we do that, we can calculate the time difference. Where say, for example, we have traffic data minus, for exit time and entry time, and this would just give us the amount of time that was spent maybe by, the vehicle. That could be maybe the parking data. Then we can display the updated data set with the calculated time difference. And you can see how much in terms of time difference we have. All right, pause the video and then work on the challenge. In some other situations, we might want to maybe add days to the data that we are working with. It could be that we might need to project maybe deadlines, schedule events, etc. So assuming that we have this data set that contains the following information: entry and exit time, we could decide to maybe add days in order to maybe calculate maybe a set deadline for the projects that are there, or whatever that you might be intending to achieve. So initially, again, convert the data that we want to work with to have the date time format. And then once we do that, we can decide to calculate maybe future dates by, say, you can add the date by days. Maybe we can add 3 days using now PD day offset. Then we specify days to now that particular date time column that we want, and then that will be stored in future dates, which we store in a new future date column. We could have actually copied this in here, but it's okay. You can just see that. So future date, it's actually the one on the far right. It should be 3 days after entry time. So after entry time, should be able to see this is 3 days after. So this is 4th, and this is 1st. Right, pause the video and then work on the challenge. In some other situations, we might want to not subtract days or add days. We might want to subtract weeks. We can still work with weeks just as we did with days, such as we did here. We could decide to say, let's load this data. And then we can decide to maybe subtract 2 weeks, still using PD date offset, and we specify the weeks in there. We again subtract 2 weeks from this particular column, and we display that. So you should have this date, but now 2 weeks before. This is what we have. Right, pause the video and then work on the challenge. In some other situations, we might want to handle daylight saving time changes. So assuming we have this data set that we should be able to see here, if we wanted to maybe accurately, convert our date to have some sort of time zone, again, we can do the same thing. Actually, this just involves that we had also covered in the past. It's almost the same thing. Actually, it's the same thing. The only thing is that almost the same thing. The only thing is that if we wanted to convert maybe a specific date from a specific time zone to another time zone, then we would need to do the following. First of all, convert the date time column that contains our date information. And then once we do that, we can decide to, like in our case here, we will have set that our original timestamp column has the UTC time zone, so we can convert that data to have US Eastern time zone as shown here. Then we can have that as a result. So that we can. So in our case here, we actually have US Eastern time zone that we see here. Pause the video and then work on the challenge. Lastly, moving on, we can decide to group data, so create pivot tables from a bigger table. So assuming we have this data, we can decide to convert the date column to date time format. And how we can do that, we can decide to use, first of all, we convert our date column to have a date time format. And then once we do that, we can use the group by function or group by method. And we specify the column that we want to group the dates with. So in our pivot table, we want months on the left-hand side, which we extract the month component from the date column, but we could always create a new column and have that separately and pass it to group by. Then we apply our aggregate function and we specify the aggregate functions that we want that would lead to the information that we need in that pivot table. So we'll have months, then the mean speed, the maximum, the sum of volume, the total number of accidents, and we can display that. There we have it. Right, pause the video and then work on the challenge. So yeah, so that's it with regards to this learning experience. I hope you were able to find some value and you can be able now to go forth and work on projects still using the same concepts that we've worked on so far and answer research problems that probably create an impact in the organization or the community involved. If you did love this experience, be sure to give this video a thumbs up. It tells us that we're doing a good job. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. All the best in your learning journey. Bye-bye.